Welcome to Yengel's algorithm series for absolute beginners. Today we're going to learn about bubble sort algorithm. Let's say we have an input list containing numbers in random order. If we have to write a program that sorts this input list in either ascending or in descending order, then bubble sort algorithm is a technique which we can employ to accomplish this task. Now, let's try to understand the logic behind bubble sort. Our sample input is sorted in descending order. We're going to employ bubble sort to sort it in ascending order. Now, let's try and see if we can visualize what's happening inside a bubble sort algorithm. The core of our algorithm takes in two inputs, it compares the value with one another, and then it rearranges them or switches them if necessary, and then insert them back into our input list. Our algorithm takes in two inputs, it compares their value using a greater than symbol because we are going for an ascending sort. It switches their places if necessary, and then it reinserts them into our input list. Nice. Our job here is not finished yet. We move on to the next set of value and we perform the same operation all over again. We compare them and then we perform a switch if necessary. We paste them back into our input list. Now, do the same thing for the last pair of value. Nice. After our first pass, can you see what we have done to our input list? You guessed it. We have successfully moved the highest value of our input list to the rightmost corner of our output list. Well, that seems to fit our ascending sort narrative. But not all the values in our list have been sorted yet. So let's perform our sorting operation again on this output. This is what we refer to as the second pass. Well, you must be familiar with this process by now. So I'm going to let you observe the process for a while. We're not going to perform the last comparison. Can you guess why? You guessed it. During the first pass, we moved the highest value to the rightmost corner. So even if we were to compare the last pair, it's not going to change. There we have it. After the second pass, we have successfully moved the second highest value in our input list to its rightful spot on the output list. Well, it seems we still have some unsorted data in our list. Let's fix that. How? We go for a third pass. We perform the usual compare and switch operation for the first pair and then paste them back into our input list. Comparing the next pair of value is a waste of time because during the first two passes, the highest number and the second highest number have been moved to their respective places within the list. So even if we were to compare the subsequent pairs, their ordering is not going to change within the list. There, finally, we have got our array sorted in ascending order. From this analysis, we can understand that during each pass, the corresponding highest value was moved to its rightful spot within the list. This also gives us a hint. In worst case scenario, if our input list has n number of items, then we have to perform n-1 number of passes to get our input list completely sorted. Now, let's move on to the coding section. Understanding the logic of your algorithm is one thing, but writing an efficient algorithm in a language of your choice is a whole new game. We have chosen Python as our programming language for this demonstration purpose, and the code snippet which you see in your screen right now is a standard textbook example of bubble sort. Let's try to understand it, shall we? When we provide our snippet here with an input list containing values to be sorted, the first thing it does is it calculates the length of our input list. And using this value, it creates a list in its memory containing length minus one number of items. The value of this constructed list ranges from length minus 1 till 1. There's a brilliant reason behind constructing such a list. We'll take a look at it shortly. Now, we loop through each and every value of this constructed list as highlighted in our code snippet above. And for each iteration, we construct a new list with values ranging from 0 till the number themselves minus 1. If constructing these lists in memory seems to be confusing right now, don't worry, we'll take care of it pretty soon. Now we have got a nested loop here. For every item in this newly constructed list, we perform a compare and switch operation. Now we have gone through an overview of this code snippet. Let's try and see if we can visualize this code in action. The program takes the input list and it creates a new list in its memory containing values from length -1 till 1. We take the first value from our constructed list and then create a whole new list with values ranging from 0 till the number -1 themselves. The values inside our list highlighted in red represents our index value. For every value in this list, we perform a compare and switch operation with its neighboring value. Once it's done, we move on to the next value in our list and perform the same operation again. We compare the value of this index with its neighboring value, and if necessary, we perform a switch operation. Notice how our loop is not going any further, because if we do, we'll be getting an array out of bound exception. There, after the first complete iteration, we have moved the highest value to the rightmost corner of our list. Now, let's get ready for our second pass. The result from our first pass will become the input for our second pass. I think a pattern is starting to emerge. Let's see if we can dig deep to get a clear picture. We take the number from our outer loop and we construct a new list with values ranging from 0 till the number -1 themselves. And for every index value in our highlighted list, we perform a compare and switch operation with the neighboring value. Let's look at our program in action. Compare and switch. Move to the next value. Compare it with the neighboring one. Compare and switch. Notice how the list for our second pass stops at the exact right spot. We don't have to perform any more comparison because during the first pass, the highest value has been moved to the right. So even if we were to perform any comparison, it's not going to change the order. See, that's the beauty of this code. Now let's move on to our third pass. We construct a list in our memory, and we perform the same operation again. We take the value at the specified index, we fetch the neighboring value, we compare it, and we perform a switch if necessary. Nice. It seems we don't have to perform any more operation. The algorithm has successfully executed all the requested iterations. Just out of curiosity, if we were to perform any further comparison, we find out that it doesn't have any real impact on our output. The loop stops right here, and there's a brilliant reason behind it, because during the first two passes, the highest number and the second highest number have been moved on to their respective position. So any further comparison among them is simply a waste of computational time. There we have it. Our input has successfully been sorted using bubble sort algorithm. If you really want to appreciate the brilliance of this small piece of code, try to read about bubble sort algorithm and then come up with your own implementation of it. Just take a look at my attempt in implementing bubble sort algorithm. It gets the job done, but the code snippet from the book is a much more robust implementation of the bubble sort algorithm. Hope you guys found this video helpful. See you guys in the next one. If you guys like our work, consider subscribing to our YouTube channel for more educational content.